Hi, this is John Guest, and this is going to be a short video to go with the volume 35, number 3 of the Economic Review, and in particular this is linked to some of the questions on the article on the Northern Powerhouse. So question 2 in that article is explain what is meant by lumpiness in the production process, and I've provided some written notes already on that in the online resources. But the second part of that question said draw a diagram to illustrate how lumpiness in production can create economies of scale. So let's draw a diagram to illustrate that. So to start off, we've just got costs on the vertical or y-axis, output on the horizontal or x-axis. And to start with, we're going to draw this green short run average total cost curve. And we're going to assume this is an average cost curve for a production process that's got a fairly smallish share of capital inputs. So in terms of the previous answer, the share of the sort of lumpy inputs is pretty low. This is a more labour intensive method of production. And then we're going to draw another short run cost curve, the blue line or SRATC2, and this is for a far more capital intensive method of production. So there's going to be some considerable lumpy or indivisible assets here. So this could be either what happens, this could be the cost curve, sorry, that represents automating an assembly line, or if you ever watch any videos on an Amazon warehouse, you'll see how they use these Kiva robots. So this cost curve could represent switching a warehouse over from a very labour intensive method to organise and pick things in the warehouse to using a very capital intensive robotic method to do it. Now obviously the capital methods, the robotic methods, the automating the assembly line, these can't be done gradually. So to put that another way, as you increase output on this axis, the usage of these inputs, the quantity of them being used, doesn't move in proportion to that change in output. With the green line they do. This is a production method that's got lots of divisible inputs. So remember the divisible inputs, the things like raw materials and maybe labour to some extent, where if you increase output, the quantity of the inputs you use sort of approximately moves in proportion to the increase in output. So what does this illustrate? Well, let's imagine that you produced Q1 as a level of output. We can see here that on the green short run average total cost curve, so remember this is the cost curve that represents the production method with lots of divisible inputs, so there's not much lumpiness. We can see that the average total costs of using that production method are much lower than using the much more capital intensive method. The problem here is often with lumpy or indivisible inputs like automation and using these robots, is that they can't be scaled down below a certain size. So you can't automate half an assembly line. You couldn't have robots on half the warehouse floor in Amazon. So you have to do these to a certain level. There's a certain minimum scale that you have to use these inputs to, and the problem at Q1 is the output levels are too small to spread those capital costs over, so the average cost is pretty small, whereas with the green average total cost curve that represents the production methods that's using the more divisible inputs, well, remember they're moving much more in proportion to the amount of output that I'm using, that I'm increasing by. So in this situation it's far cheaper for the firm at this output level to use a less capital intensive method of production, and one using far more divisible inputs. But we can see that as output expands, so we get a Q star, which is where the two lines cross at point C. Now whether we used our capital intensive or our other method of production, the average total costs would be the same. What's happening now is as I increase output, I'm going to have to spread those costs that I've invested in the lumpy or indivisible input over a much bigger scale of output, and that's bringing the costs down. Then if I actually start producing Q2, we can see that the costs of using the more capital intensive method of production with the lumpy assets actually gets smaller. Now the output run is so big that we're able to spread that fixed that investment in those fixed capital assets over a much greater output, and that's bringing the average total costs down. So now producing Q2, it is far cheaper to use the capital intensive method of production than the method of production that's using more of the much more divisible inputs. Now what this means is that as we expand production, as we expand output in the long run, we obviously would travel down the green line to begin with, because that's the lowest or the cheapest average total costs. And then once we get to output levels beyond Q star, it would pay us to switch to the more capital intensive method of production. So now it pays us to automate the assembly line or to invest in the robots, because we can get enough output to reduce the average costs or to spread those capital costs over a much bigger output. So the long run average total cost curve, we'd follow along the green line to point C, and then we'd switch onto the blue line, because remember, in the long run we can change everything. We can now automate the factory. So our cost curve, we travel along the green line from B to C, and then our long run average cost curve would be from C down the blue line to E. And this is really illustrating economies of scale, because in the long run, as we can change all our inputs in production, including those indivisible lumpy ones, we can benefit from economies of scale, invest in those inputs, and start using production methods that give us much lower costs. So hopefully this little simple diagram showing us the relationship between the two short run average total cost curves and the long run average total cost curve can explain how these indivisibilities of inputs in production could generate quite significant economies of scale. I hope you found that video useful, and obviously that goes with question 2, where there's some written answers that just outline what we mean by lumpy or indivisible assets, or inputs.